Imagine a small grid. Let's start simple, say a 6 by 6. If we selected random pixels in the grid to be filled in, we would get something that looked like TV static most of the time, but at some point, it would be possible to generate this, for example, which we would all clearly recognize as a plus sign. Scale up the experiment. If we limit ourselves to only 2 colors to make it as simple as possible, let's consider, say, a 28 by 28 image. What is the minimum amount of information we actually need until a recognizable form appears from the chaos? Of all the possible images in there, which one is specifically the one we are looking for? I've created this app, Bunna, to answer those questions. Now go on a journey of imagination with me. While most all possible variations of a 28 by 28 grid would usually look like unintelligible TV snow, theoretically, if you did have time to look at every possible generation of this grid one by one, 1 second at a time, eventually you would arrive at this one, image number out of the total amount possible. However, the problem is you would still need far more seconds than the estimated lifespan of the universe, and you would still not see all the possible images. And yet the bunny is one of these known images. This one right here. What hidden images besides the bunny would emerge just in that little 28 by 28 grid? Who else is in there waiting for us besides just the bunny? What possible futures unknown could be revealed? The only thing stopping you from seeing these unknown futures is the fact that you'll not live nearly long enough to look through all the possible images in your lifetime, even if you reviewed multiple images per second. If you reached a high enough resolution, scaling this grid up to thousands or millions of pixels across, hiding in that grid would be every invention humanity's ever made, every page of text ever written, a photo of every face that's ever existed in all of creation. And if capturing it in just black and white pixels did not capture the scene well enough, you can simply raise the base of this exponent pair in our grid experiment to multiply our existing problem space by the number of all possible colors. Scaling this up, it's easy to conceive of a grid that's non-differentiable from an HD camera photo. The computational time to sit and look at each of these randomly generated images at such a color and resolution, it staggeringly approaches infinity very quickly. And yet, it's mathematically provable that every photo your HD camera could conceivably ever take already exists in the defined set of known possible images. The implications of Bunna are pretty heavy when it comes to thinking about computational time.